For number 3, our first step is going to be to rewrite it because I think it makes it easier if I use a negative exponent instead of viewing it as a fraction. Okay, so I want to use a u substitution. So I'm going to let u equal the thing that's in the parentheses. So 6x plus 1. And then again, our next step is to actually take the derivative. So du is equal to 6 dx. And then I want to solve for dx. So if I divide both sides by 6, I get 1 over 6 du is equal to dx. So this is all the information that I need in order to do the substitution. So I have the 6x plus 1 being replaced by u, and then I have the dx, and I do need to replace my dx with du, otherwise what I'm integrating with and so like what I'm integrating with respect to and the variable, they need to match. So that's why I need to do both parts. So my new problem is 4u to the negative 3 times 1/6 du. So if you integrate, let's move that 4 over 6 out to the front. Again, with constants that are being multiplied by our variables, we can always do that. So u to the negative 3 is going to become u to the negative 2 divided by negative 2 plus c. So then let's do some reducing. This will be negative 4 over 12 u to the negative 2 plus c. And if I reduce that, let's go to the next slide. I can reduce that to negative 1/3 u to the negative 2 plus c. And then I want to sub back in. So negative 1/3 6x plus 1 to the negative 2 plus c. And that'll be okay for a final answer. If you wanted to put it on the denominator, you could. So it would be like negative 1 over 3 6x plus 1 squared plus c. But that's not necessary, so either way is okay.